This research has been titled as can be seen. In this study, we aim to synthesize titanium dioxide nanoparticles using the deep coating method on a layer of zinc oxide nanoseeds that had already been generated by radio frequency scattering on a flexible Teflon substrate for the first time in this condition. Zinc oxide is a semiconductor material with a large energy band gap 3.37 electron volt. The concerns are in rapid photodegradation and the existence of interstitial levels between the valence band and the conduction band. Zinc oxide nanocomposites come in a wide variety of forms. Zinc oxide forms produced using many different processes as can be seen. Titanium dioxide is normally using for photocatalysis and nanophotonic applications. It has stability and band gap value of 3.2 electron volt. Titanium dioxide could also be created using many methods. It is interesting to note that the desired nanostructure shape can be easily achieved by soft chemical process like deep coating procedure. The previous results showed that their characteristics had already greatly altered based on the binary titanium dioxide zinc oxide nanocomposites using either physical or chemical procedures. In this study, titanium dioxide nanoparticle with zinc oxide nanoseeds films were grown on PTFE substrate using deep coating process. The experimental method is summarized as the titanium dioxide was prepared by combining specific amount of titanium dioxide powder added to specific volume of ethanol inside closed bottle. The mixture was processed under the sonication system at a 60 Celsius for 5 hours. The output was titanium dioxide nanofluid. The substrate was cut into 1 centimeter square dimension and it was cleaned in isopropyl alcohol under sonication, then washed by deionized water. Afterwards, a 30 nanometer seed layer of zinc oxide thin film was spattered on the substrate using a zinc oxide pure target by RF spattering equipment under specific conditions as can be seen in the article and the current slide. For deep coating process, the sample was exposed to the many conditions as can be seen in the slide and the manuscript. The characterization shown devices were responsible of the characterizations. For the results and discussion, Figure 1A shows The zinc oxide thin film was grown as a nanoseeds on a PTFE substrate that was deposited by RF sputtering. Figure 1b shows the agglomerated nanoparticles of the titanium dioxide heterostructure synthesized by deep coating process on a previous observed deposition as seen in a figure A. Figure 2A and B elucidate the atomic percentages obtained by EDX for the sample of the zinc oxide nanoseeds on PTFE substrate, and the sample of the heterojunction synthesizes on PTFE substrate respectively. In the seventh slide, the XRD analysis allows for the interpretations of the peak properties of the ground heterostructure on the PTFE substrate. As can be shown in figure 3, the peaks of the used components were joined to Miller indices. The names of the used components labeled in the figure can be seen at the map guide of materials on the right. Diffused reflectance spectra. Figure 4 elucidates the plot of the UV visible diffused reflectance spectra for the synthesis heterojunction on a PTFE substrate, which calculated by Kibble-Gammang relation. It was found that energy band gap of the sample has a value of 3.3 electron volt. This value is a particular in between the typical band gap energy of titanium dioxide and zinc oxide. Photoluminescence analysis, figure 5, revealed that there was a weak emission peak in the UV region and broad emission peak in the visible region was observed due to the presence of OH groups. This can contribute to the shift, which is dominant by interstitial oxygen for the delay of the photo degradation. A high number of point defects with the band gap contributes to a low ratio of intensity of UV with respect to intensity of the visible in the prepared hetero thin film. More descriptions could be found in the references. Figure 6 illustrates FTIR spectrum patterns of the heterojunction composite on the PTFE substrate. The vibrational bond modes properties between ions can also be confirmed by the performance of the titanium doped zinc oxide. The bond of zinc and oxide were accepted, and the existence of OH groups, which mean the presence of the photocatalysis. More properties has been justified by the following citations on the right side references. We can conclude that the deep coating process was used successfully to create heterostructure of titanium dioxide nanoparticles and zinc oxide nanoseeds composites for the first time on the Teflon substrate. FSIM images and EDX analysis revealed the nanocomposites and the whole components of used elements. The significant peak in XRD analysis was at 34.43 degree, which indicated the incorporations between titanium and zinc oxide at the boundary layers. The UV visible Kibelgamang study revealed that the energy band gap is 3.3 electron volt as interfacial band gap. The significance of the photocatalysis properties was afterward disclosed by photoluminescence analysis as a result of the careful experiment design, which was highlighted by intensity of UV with respect to intensity of visible light less than 1. The OH group, hydroxyl group, and its vibrational presence with titanium as well as other defined bonds, shoulders, peaks, which coincide with the earlier statements, were reinforced by FTIR pattern. Acknowledgement and the reference. Thank you for watching.